All right, guys, today we are going to go over gas stoichiometry. So we are going to combine two topics, stoichiometry, in which we do gram to mole or mole to gram conversions, along with our gases. This is important because oftentimes reactions generate a gas as a product, and we have to be able to calculate how much gas it is that we made. So we can do that using our equation PV equals nRT. If you are not familiar with the ideal gas law, please check out my earlier video that is linked above for tips on how to use the ideal gas law. All right, with the ideal gas law, a brief recap here. We have to make sure we know what the variables mean. P measures pressure, V is volume, N is moles, R is a constant, and T is our temperature. Now, this equation is unit specific, so we need to make sure that we are using the appropriate units. In these problems, I am going to use ATM for my pressure. You could also use kPa, but if you do use kPa as your pressure, please note that your R value will change as a result. Volume is going to be measured in liters. Moles will be measured in moles. R is a constant, and that constant is 0.0821. That constant, though, must only be used when we are using ATM, liters, moles, and Kelvin. So that's the unit on my constant, and temperature must always be measured in Kelvin. That means we have a couple of important equations or conversions that we might need in addition to our ideal gas law. First is Celsius. If we are given a temperature in Celsius, we can easily convert from Celsius to Kelvin by simply adding 273. This must be done prior to using the ideal gas law. The second thing that we need to know is that there are 1,000 milliliters in 1 liter. So if you are given a volume in milliliters, you may need to convert those milliliters into liters using that conversion factor. All right, let's get started on our first problem here. How many liters of NH3 gas can be produced from 22 grams of H2 at 0.98 ATM and 75 degrees Celsius? There's a lot going on in these problems, so I think it's really important to organize your information, figure out what you know, and where you're going before you begin. So the first step that I always do when I'm approaching one of these problems is identify what variables I have and what substance they're referring to. So I'm going to go through, and I have grams of H2, so I'm going to write my 22 grams of H2 underneath the substance in the balanced equation that it's referring to. My end goal here is to find how many liters of NH3 gas. Remember that liters is a measure of volume, so my end goal here is to find the volume of my NH3 gas that is produced in this reaction. I know some additional information. This reaction was run at 0.98 ATM and 75 degrees Celsius. Those two values apply to everything in this equation. Those are the conditions of the reaction, but they are only going to matter if we have a gas. So we know NH3 is the gas, and we know that this is the gas that we are trying to determine the volume of. So the pressure is going to play a role in calculating our volume. We also have a temperature. Our temperature is 75 degrees Celsius. So I've listed everything that I know, and I've identified my ultimate goal here, or my endpoint, which is to find the volume. Because NH3 is a gas, the equation PV equals nRT, or ideal gas law, is going to be important here. If you notice, I have P and V, but I have not identified N or R. R is a constant, and as long as I have ATM, liters, moles, and Kelvin, my R value will be 0.0821. The units on the R value are ATM, liters, or moles, Kelvin, and this serves as a good reminder to double check that you have the proper units. I have ATM here, but notice that I have Celsius. I need to have Kelvin, so I'm going to add 273, which gives me 348 Kelvin. Everything is in the correct units, so now let's come up with a plan. Notice that I can't use the PV equals nRT equation at the moment because I'm missing 2 out of the 5 variables. I'm only ready to use the equation when I'm missing just one variable, so I'm going to have to figure out a way to get the n value. If I can get the n value, and remember that n is moles, if I can find the moles of NH3, then at that point I can use my PV equals nRT. Remember that I have one other key important piece of information. I know that I have 22 grams of H2. So I can use stoichiometry to convert my grams of H2 into moles of NH3 using the mole ratio for my balanced equation. Once I have my moles of NH3, I'll be able to solve using the ideal gas law. 22 grams of H2 is my starting point. I would like to use the ratio between the H2 and the NH3, but remember that ratio only works when you're in the unit of moles. So I'm going to convert my grams of H2 into moles of H2 using the periodic table. When I go to the periodic table, I add up 2 hydrogens, and that tells me 2.02 grams are in 1 mole. Now, I have moles, but notice that this is moles of H2, and I need moles of NH3 here. I am going to need to use my mole ratio to compare the two. For every 3 moles of H2, according to my balanced equation, I will produce 2 moles of NH3. Now, the only unit left that has not canceled out in my stoichiometry problem is the moles of NH3. As soon as I have the unit that I'm looking for, I'm ready to solve. Multiply across the top, multiply across the bottom, divide the top by the bottom, and I end up with 7.26 moles of NH3. I now know this number right here. Notice that now that I have moles of NH3, I have 4 out of the 5 variables, so I'm ready to solve for volume. In order to solve for volume, I'm going to use my equation PV equals nRT, and I'm going to substitute in the numbers. Instead of pressure, I'm going to put 0.98 atm. Instead of volume, I'm going to call that x, since that is my unknown variable. My n value is what we just calculated, 7.26. The r is 0.0821, and the temperature is 348 Kelvin. Now that I have everything substituted in, I can solve for x, and x is equal to 212. It's important to put a unit on your final answer, so remember that my volume is going to come out in the unit of liters because that was the unit in my constant. I know that I'll be able to produce 212 liters of NH3 gas if I start with 22 grams of hydrogen. One thing that can be tricky about our gas stoichiometry problems is that they don't all give us the same information or ask for the same endpoint. So making sure that you don't memorize a series of steps is key here. The steps will be in a different order every time. So instead, if you approach these by determining what you know and what you're trying to find, determine a pathway, and then do the math. The question asks how many grams of aluminum are needed to produce 125 milliliters of H2 gas at 20 degrees Celsius and 0.99 atm. I have a balanced equation written here, and I'm going to go through and identify what my numbers represent. This is milliliters, and specifically milliliters of H2 gas. I know my H2 is a gas. I know the volume is 125 milliliters. Next, I have 20 degrees Celsius, and remember that that temperature and the pressure are going to impact my gas. I've determined that hydrogen is a gas, so the temperature is 20 degrees Celsius, and the pressure is 0.99 atm. All right, now I need to determine what is my endpoint, what is my ultimate goal here. I'm trying to find grams of Al. So I need to figure out how many grams of Al I need in order to produce 125 milliliters of gas. Let's take a look at what we know about the H2. We know the V, T, and P. Our equation is PV equals nRT. I'm missing the n variable and the r variable. When we have ATM, the r value will be 0.0821, and again, the units on this are atm liters over moles Kelvin, so I need to make sure that I have the rest of the units correct as well. Notice that here I have milliliters, not liters. That means I'm going to have to convert prior to using my equation. There are 1,000 milliliters in 1 liter, which means that this is equivalent to 0.125 liters. So I have ATM, I have liters. My N is going to be in the unit of moles, and I also need Kelvin. So since I have Celsius at the moment, I'm going to need to add 273 in order to get 293 Kelvin. Now I've got all the right units. All right, let's see if we can come up with a plan here. If I start with my PV equals nRT equation, notice that this time I have 4 out of the 5 variables. If I have 4 out of the 5 variables, I'm ready to use the equation and solve for the unknown, which in this case is moles. But it's important to remember that when I get moles, that is going to be moles of H2. So as soon as I get moles of H2, I can then convert my moles of H2 into grams of aluminum using my stoichiometry and my mole ratio from the balanced equation. Again, I know 4 out of the 5 variables needed to solve for my gas law, so I'm going to plug in what I know. I've already double checked that I have the correct units, so 0.99 ATM times my volume in liters, which is 0.125, is equal to my moles, which I'm going to call X, times 0.0821, my constant, and my temperature is 293 Kelvin. When I solve for X, I end up with 0.00514. Remember to keep track of the unit and the substance. So this X was representing my variable N, and N is moles. This is moles, and specifically, because this entire equation pertained to the H2, this is moles of H2. My end goal in this problem is to find grams of aluminum. Well, the only way to relate two different substances in a balanced equation is through the mole ratio. Since I have moles, I'm ready to use that 2:3 ratio, and I'm going to put 3 moles of H2 on the bottom and 2 moles of Al on the top. Now I have moles of Al, but the problem asked me for grams of Al. I'm going to go one step further. 1 mole of Al is equivalent to 26.98 grams of Al according to the periodic table. When I solve the problem, the only unit that remains is grams of aluminum. And when I multiply the top together, multiply the bottom together and divide the top by the bottom, I end up with 0.928 grams of aluminum. So if I want to produce 125 milliliters of hydrogen gas through this reaction here at 20 degrees Celsius and 0.99 ATM, I know that I'm going to need to start with 0.0928 grams of aluminum. I hope that cleared up your questions on gas stoichiometry. Thank you for watching, and check out my other videos.